Welcome to Scott++. In this video, we're going to look at some tricks for NodeJS web app development. These are going to be some very specific things that I stumbled on while developing the star voting app. Hopefully you can avoid the same mistakes and losing hours of time debugging like I did. We're going to look at testing with Jest, catching your promises, and more right after the intro. As in previous videos, we're working on a star voting web app, which lets you host and run an election using star voting, which of course is the voting method that picks the candidates that best represent the voters' values. It's a pretty typical tech stack. We've got Node.js, Express, Postgres, and React running on the front end. So let's dive into the first issue, which is mocking with Jest. All right, so this one comes with a bit of a backstory. Initially, this is how we had set up our mocks. So each of the databases that we needed to use in a test, we would mock out individually. So here we're mocking out the ballot store, the election store, and the election roll store. So in the test, whenever we are needing to use a database, Jest is replacing the calls to this database abstraction with our mock. So for each of these, we wrote a mock that would effectively save the data in local memory, probably in an array or something like that. And this worked fine until we got to the cast vote controller. In the cast vote controller, obviously the user is voting. We need to record the vote and also update our list of eligible voters to show that they voted so that they can't vote again. So that means we need to write to two databases, or at least two tables, in a single transaction. So we added this cast vote store, which handles that. So it puts into a single SQL statement here, both the writes, and it does that atomically. Now, in order to mock that, our cast vote store mock, we need to make sure that we are writing to the same data that the other mocks are using, right? We can't have a cast vote store mock having its own copy of state, because later on in the test, when we go to read from, for example, the ballot store and read that the vote had indeed been saved, that wouldn't work. So how we handled this is we needed to take more control over how these mocks were being set up. So instead of mocking out each of the stores individually, we instead went to mocking out the entire service locator. So we had been using the service locator pattern. So basically this was a static class that had a bunch of methods to access a lot of the global dependencies for the app, the cast vote store, the email service, etc. So whenever it was providing one of these, it would check if it already had an instance of it. If not, it would create one and then hand it down. And so then in the mock service locator, when the user is requesting the cast vote store, we can put into the mock the same ballot store and election roll store that the service locator would be providing. So again, instead of mocking the individual databases, we moved to mocking the entire service locator. That gave us more control over how these things were assembled. That finally sets the stage for our problem to arise. When we went to implement the finalized election controller, as part of this flow, we send out a bunch of emails to everyone registered for the election with their individual voter link. Obviously, that's not something we want to do during a test, so we mock out the email service. Then in the test for finalized election, here we have the test helper, and down here we reach into the test helper, grab the email service, and check that it actually sent the emails, or at least that it pretended to send the emails. And this test was failing. Even though we added some logs to the mock email service, we could see it logging out that it was indeed pretending to send the emails, but this test kept failing. It was still at 0. And this led to kind of a big discovery. In the test helper, we see that we are reaching into the service locator, specifically the mock service locator. And when we set things up here, we're grabbing the email service and storing that reference, specifically so that later a test can go in and inspect that. But it turned out that the entire service locator that this test helper had a reference to was an entirely different instance of a service locator than the one Jest was providing. So again, here with Jest, we're mocking out the service locator. So everywhere else in the code, when people are calling into the service locator, they're instead directed to the mock service locator. But it turned out to be a different instance of the mock service locator than what the test helper was grabbing, even though it's a static class with all static variables. So that isn't what I would have expected, and something to be careful of in your own projects. So in our case, the simple fix for this is just to remove the reference to the mock service locator in the test helper. So now when the test helper asks for the service locator, Jest will mock that as well and provide the same instance of the mock service locator that is providing everywhere else. The main problem with this is that we lose the ability to call the mock email service in a type-safe way. The signature for our mock email service is slightly different than the production email service. We have extra methods that allow us to inspect the emails that it claims to be sending, right? Now, because the test helper has to grab the production service locator, it thinks by its signature that it has a production email service, or maybe a interface for the email service. We can't actually store a reference to the mock email service. Now, because this is JavaScript, that doesn't stop us from asking for this sent emails property, even though it shouldn't exist. So that is what it is. If we wanted to solve this in a truly type-safe way, we might take another step towards full dependency injection and set the service locator up as a singleton, similar to what we did for the logger. In our logger, this is a static class that has a reference to a single implementation of a iLogger interface. And then all of the static methods on the logger class, debug, info, warn, etc., effectively just route and wrap calls to that specific interface. Now, what that lets us do is we can have a function here like setLoggerInstance, and we can swap out the implementation of effectively all this code on this static class with a different implementation when we're running a test. And that is exactly what we're doing here in the test helper. At the beginning of each test, we're effectively injecting the test logger into that singleton. So we could transition to do something like that for the entire service locator, right? We have our service locator, we have our mock service locator. We could swap that into a singleton that has the different implementations, and then we control which version we're using and when, instead of relying on kind of just magic to do some mocking. Now, some people do think the singleton is a bit of a code smell. Another way to solve this would be to go full-blown dependency injection. The current issue with that is that currently all of our handlers, these are just functions, right? So if we wanted to pass down all of their dependencies, we would effectively need to either wrap these in an object that we can pass the dependencies into instead of them reaching out to the service locator to get their dependencies. Or when we are calling the route through Express, instead of directly calling this function, we would pass in a function that takes those dependencies and then returns back a handler. Either way, that's going to be a lot more code, in my opinion, kind of boilerplate. So in this situation, the singleton and the service locator, for me, it's worth the price, right? Now, you do want to keep an eye out if it starts getting, you don't want too many singletons floating around in your system, right? That can be messy. And there are limitations. If, for example, we wanted to run a test where we had 2 instances of our app running, and maybe they had different dependencies, and we want to do a test where they talk to each other or something like that, the singleton solution does not work in that case, because the name singleton implies you can only host one of these. And if you wanted something like that, you will need to go full-blown dependency injection so that you can, when you're building each of these apps, pass down different copies of their dependencies. But for us right now, this is working. So all that to say, keep in mind how the Jest mock works, that when Jest is mocking something, it's giving you a different instance of that mock than if you try to reach into the mock code yourself. Those are going to be different instances, and it might cause you trouble. Okay, this has been a saga. Let's go ahead and roll on to the next issues, which I'm pretty sure will be a little more concise. Okay, the next issue I want to take a look at is catching promises. I set up a quick demo for this one. We had pulled in a HTTP errors library, which has a lot of very useful types for throwing errors like not implemented, bad requests, etc. So you can basically just throw one of those typed errors, and theoretically that should then send the appropriate response to the client. So for this demo, I just set up a very single handler, catches demo, and then it just throws this not implemented error. And then in the test, I'm just expecting that the response is a 501. So when I run this test, npm test catch demo, here we see I got a timeout, which is not what we want. And so why is that? There is a great npm package that handles this and explains why it works. In standard express, you need to catch your own errors and pass those into the next handler in the stack. And so this very simple async handler function, whenever you're setting up your routes, you can just wrap it in this async handler and it will do that for you. So real quick, if I just wrap this in the async handler function, save, run the test again, and now we're good to go. All to say, in Express, be sure to be catching your promises and pass them in to the next handler so it can eventually return that response to the client. And I'll leave links to both the packages we use for the HTTP errors and the async handler in the description. All right, next. All right, last issue for today. In previous issues, I talked about trying to ensure that your mock databases mimic the behavior of a production database as well as possible. And here's an issue where we didn't go far enough. In this mock election role store, I was working on a route where we would save some data, update that the user had voted, and then try to read that back out later. And I was getting different values. And I got to the point where I added a call to immediately after I saved, then try to read it back out of the mock database, and they were coming back different. And I'm like, what is going on here? It turned out because we're just using an array to store the data, there was an earlier part of the flow that had already saved an election roll with the same ID. And so then when we were pulling that back out, it was grabbing the first one it found that matched the filters, which was different than the one that I had just saved. So I went in and added this little debugger clause. So if you're mocking anyway, you might as well help your users and other people on your team who are testing to point out any potential errors that might be coming up. So in this case, if we are saving an election roll and we see that an election roll with the same ID already exists, in this case, I go ahead and log an error to let them know maybe something's wrong in their flow, that they're saving this thing twice. So just another reminder, when you're building out your mock database behavior, try to make sure that it is as close to an actual database as possible. Back when I was working on tag share in Hacks, I actually built out a more robust local memory database kind of a mock, or something that could be used for a mock. Basically, it would take a data model where you would have to specify all your fields and which one you might want to use as indexes. And then in local memory, it would store a map from all the field names to a map of all the objects held by those keys. So that way, whenever there was a conflict, it would override like a database would do, instead of storing multiple copies of things with the same key. That might be something I want to explore more on the JavaScript side of things. There are probably solutions out there that already exist, so we stop running into these problems of our mock databases behaving differently than a production database. But that is probably not the highest priority right now. Looking forward for the Star Voting project, probably going to be shifting things to more of an event-driven architecture, at least for casting votes, with the introduction of the email service and now wanting to send an email confirmation when a user casts their ballot. There are now more things that we want to be sure to handle atomically from some of these routes. So I'll be exploring that more and talking about it in future videos. But that's it for me today. Hopefully this type of video where I dive very deep into some of the specific issues I struggle with when building this Node.js app is useful for you. If there is different type of content that you would like to see, please leave a comment, as I'm always trying to iterate on this whole endeavor. As always, thank you for watching, and I'll see you in the next video. In this video, we're going to look at some tricks for Node.js